Swayam Prabha. Digital India. Educated India.
Hello everyone. So, our present discussion would be the airbags in automobiles for human protection. So, airbags are basically very specialized textile material which helps in the protection of the passengers and the driver during any accident. So, here we will try to understand the different types of textile materials which are used for airbags and what are their mechanisms. So, few aspects we will try to discuss here. So, what is an airbag? This is for the safety at any vehicle. So, it is a vehicle safety device which is occupant restraint system which extend. So, which actually inflate extremely quickly and then deflates, that is the system. This is the bag, this will be inflated very quickly. There is a folded bag, suppose it is a folded bag, this will be inflated very quickly and again deflates. The active safeties are that brake assistant. So, it is a brake system is there. So, for better grip, anti-lock braking system, electronic stability control, etc. These are the active safety. And there, in addition to the active safety in a vehicle, in addition to the active safety in a vehicle, we have different passive safety systems. These are crumbling zones, the airbag which is the point of discussion here, then seat belts are there, trunks, electronic pedestrian protection. So, different types of safety mechanisms are there, but here we will be discussing the one specialized textile material which is airbag, which is used for protection of the occupants in the any automobile, particularly the car. Now, from this video animation we can see during any accident, you can see that airbag immediately get inflated and protect the occupant. Here in the driver is being protected. If the airbag was not there, then there will be threat. So, airbag is protecting us from any accidental threat. So, airbag contains typically, so it is in textile in a car, typically total around 42 square meters for a typical car. So, 42 square meters of materials are used, and typically 20 kgs of textile materials are used in a car. Approximately 75 million cars are sold every year in the world, and in India if we see it is typically 4.5 millions. So, airbag constitute about 3.7% of textiles used in a car. So, airbag is a very specialized material, textile material. So, here you can see in the textile material among the 42 square meter, if we see, these consist of the mainly carpet, upholstery, interior components, tire, safety belts and airbag. Airbag typically around 3.7%. If we see the market size of airbag, around 1.4 million people die globally in the road accidents. So, there and additionally 20 to 50 million people suffer fatal injuries caused by the road accident. So, the type of injuries, the type of threats, it is severe. So, according to a previous research, the global automotive airbag market size is expected to be worth around 42.16 billion by 2030, with the growth rate is 7.2%. So, 42.16 billion dollar will be there. So, Asia Pacific is the largest segment for automotive airbag market. The governments of India, Japan, China are enacting strict rule for implementing airbag for safety. So, let us try to understand the major parts of the airbag. These are the different parts. So, first is the cushion, then flexible fabric bag, inflation mold. So, there will be one mold, then airbag control unit, impact sensor. One sensor will be there, airbag will get activated only when there is an impact. So, there must be one impact sensor that will activate the system. If we see the history in 1919 the first patent was there for covering the aeroplane and other vehicle parts. So, air-filled bladders were used in 1951. In 1952, so there was another patent which was termed valuable. In 1964, Japanese automobile engineer developed an airbag safety net. Then 1967, so electromechanical crash sensor was developed to inflate an airbag in 30 millisecond, where sodium azide was used for the first time, and sodium azide is used till now also. This the first generation airbag started in 1970s, where neoprene coated nylon airbags were used. So, neoprene coated nylon airbags, and in 1970 General Motors started offering cars with airbags. Also tested the airbag with crash test after 20 years since its first patent. So, they were tested with the crash test. So, first patent was there, then there was a crash test was carried out. So, the key driving factors for airbag usage are the safety. First, it is a safety to reduce the mortality by more than 80%. Strict legislation is required, because if the government is actually make mandatory to use the airbag in automobile, then the car manufacturer will implement that. Also the consumer awareness. The person who will be buying the car, he should be aware that that airbag is going to protect us from in case of any accident. So, development of airbag for the side impact and rollover. So, from front the airbag is there, but from side impact that the airbag should be there, should work, and also during rollover the airbag should get activated. And improved technologies. So, as the technology has improved, so it has helped in using the modern airbags. Competitive dynamics also drive the usage of airbag, because one particular car manufacturer, if it actually offers the car with airbag, so his competitor will also start using the airbag there. So, the competitive dynamics are there. So, the types of airbags are, one is the frontal airbag, then side impact airbag, side curtain airbags, head side airbags, knee airbags, rear airbag, seat belt airbags, pedestrian airbag. So, these are all different types of airbags available. Now, we will discuss different airbags in details. So, frontal airbags are basically, these are frontal driver's airbag placed at the front. So, frontal passengers airbag, the passenger or driver who are sitting at the front seat. So, for them the frontal airbag is there. These are housed in the steering wheel or dashboard. So, for driver the frontal airbag is stationed in, actually housed in the steering wheel, and for the frontal passenger it is in dashboard or some places which will protect from at the frontal passenger or the driver. It requires about 1.5 to 3 square meter fabric. So, it requires about 1.5 to 3 square meter of fabric for driving and passenger side. So, 1.5 for drivers and 3 square meter for passenger side. So, passenger side requires little bit larger size, because the drivers from the driver the steering, that steering wheel, it is for drivers. So, the steering wheel is basically placed close to driver. So, for that we need smaller lower quantity of lower area. So, small size airbag, but for passenger from there dashboard is a little bit away. So, we require larger airbag. So, that is why this sizes are different. The cushion sizes are 30 to 60 liter. So, and for the this is for the driver, and passenger airbag with variable 90 to 150 liter. That type of size, cushion size is there. So, driver side airbag made for adult. So, it is assumed that the drivers will be adult. So, that driver side airbag is made for adult, while passenger side is made for variable human body size and shape and weight, like it may be the that young or maybe some adult. So, different body size, shape and weight. So, for that this driver, so passenger side frontal passenger side airbags are made. Typical dimensions of driver airbag size is, that is, diameter will be around 714 millimeter diameter and depth is 152 millimeter deep. So, that this is the shape of the airbag for driver side. After the frontal airbag, then side impact airbag, like side torso airbag, side curtain airbag, thorax side airbag, pelvis thorax airbag, head thorax airbag, door mounted airbag, rollover airbag. These are all side impact airbags. We can see from this, in case of any impact from the side, this airbag should get activated. So, that will prevent from any sorts of side impact. Side collision cause 20% of driver fatality. Installed in the backrest of the front seat. So, backrest of the front seat or behind the door trim. So, here at the backrest of the front seat it is kept, or the behind the door trim, in plates between the seat occupant and the indoor and the door. So, that during that time, so it is inflated So, between the door and the occupant. So, that will immediately inflated. Two major types. So, the types are the side curtain airbag and side torso airbag. Thorax side impact airbags are, the airbag usually have volume 8 to 10 liter. This type of airbag, small size, and it inflates 4 times faster than the frontal airbag because of the smaller size, inflates at a certain crash threshold, vehicle speed more than 15 to 20 kilometer per hour. So, at if it is more than that speed, then only this type of thorax side impact airbag will get activated. A combination of side curtain airbag and thorax airbags, that side impact airbag is highly effective. So, one is side impact airbag, side curtain airbag and thorax side impact airbag, they will be actually effective when they work in combination. Pelvis thorax airbag designed to reduce the risk of the injury to the pelvic thorax region. This type of airbags are used. The coverage area is extended by adding a cell that we can extend, deploy very fast. This concept take advantage of pelvis ability to take higher load. So, head thorax airbag protect head, chest and both, less effective than curtain airbag or rollover airbag. During the rollover crashes, mostly used in convertible cars. Door mounted airbags are there, deployed by Autoliv, a company for convertible vehicles. This is door mounted airbag. Does work in different situations such as rollover situation. Rollover airbags, 3% of all crashes are rollover. So, when the automobile moves at very high speed, then chances of rollovers are there. 33% crash related to death. So, when there is a rollover, so 33% crash related deaths are there due to the rollover. Most killed people are those who do not wear the safety belt. So, during the rollover that safety belt, it has been observed safety belt protect them, because when the fabric when the this automobile is turning, rolling, that time the position of the person inside the automobile will get changed and he will get multiple impacts. So, rollover airbag remain deployed for long time, because it is not deflated immediately, because the car or any automobile they will take multiple rollover, that is why it has to be deployed for longer time, reduce the chances of ejection of the occupant from the vehicle. So, it will prevent the ejection. Combined torso and curtain airbag protects torso and head of the occupant. This is the combined system, head and torso combination. Deploys from seat, door or from the ceiling. So, they can be placed different places. The airbag have extended portion from the main body, less effective in rollover crashes. So, center airbag which minimizes the collision with the neighboring occupants. So, between the two occupants, so there will be a center airbag. You can see this is a center airbag. Between the occupants, the center airbag will get inflated, and which is actually which will minimize the collision with the neighboring occupants. So, Honda has they have this type of airbags. Reduce the secondary injuries. So, this type of airbags for the special variant, it is not in all the cars, but for special variant they have shown this type of technology. Knee airbags reduce the knee injury. So, we can see that airbag actually inflated from the bottom of the seat to reduce the knee injury, restrict the forward movement of the knee and leg, found mostly on high end and luxury automobiles. So, it is not normal automobiles we get this type of airbags. Another important airbag is the pedestrian protection airbag. These are basically for protecting the pedestrian from getting hit by the car. So, head injury is the biggest cause of collision with the pedestrian. So, when it is the pedestrian is hit by the car, that head injury is the biggest cause of death. So, rear edge of the bonnet also rise about 4 inches. So, that hits. Now, here you can see this is the type of collision, okay. And the pedestrian protective airbag is inflated at the outside and then it protects the pedestrian. So, the incorporation and deployment system increases the cost of the car. So, there is a complex deployment system. So, this is for very expensive cars we use this type of pedestrian protection airbags. Now, there are airbags for motorcycles also. So, you can see this is actually kept within this helmet and it gets inflated and protect along with the helmet. So, this gets inflated and protect the cyclist from any sorts of major head injury. The frontal collision cause 68% injury, 71% riders injuries caused by impact with the road and different obstacles. and 25% caused by impact with an automobiles. So, now we can see this type of here during collision automatically it is this type of inflation is there. So, with the motorbike also the airbags are incorporated. So, airbags are also used in aerospace application. So, for occupant protection from striking front seat, tray table, side window, privacy wall. So, different places we can that airbags are can be placed. So, this type of systems can be incorporated. The cockpit airbags are also used, consist of frontal and lateral airbags. Airbags are also used for during the landing of the spacecraft or during landing system, that airbags are also used in manned and unmanned aircrafts. So, which is used for shock absorption and the heavy military troops. So, airdrops, for heavy military airdrops we use the airbag for shock absorption. These are the airbags. Now, let us try to understand the working principle. So, airbags inflate and deflate rapidly, okay, and sensor determine the force, okay, and immediately gets activated. When an airbag deploys, sensor may be pre-triggered. Small bump or potholes could also sense the signal. There are different types of sensors. So, crash zone sensor, impact sensor, in cabin sensor. So, the classifications of sensors are the electromechanical sensor basically. So, and the micro electromechanical sensor. So, electromechanical sensors are two type, mass type sensor and roller type sensor. So, airbag module, so that it consists of an airbag inflator and fabric cushion. So, you can see this is the airbag inflator and there will be fabric cushion, and this is the airbag mold. Fabric is actually airbag is folded and kept inside. So, airbag inflator is a small metal canister, is there within the airbag mold. So, airbag mold, within that small canister will be there which holds the explosive propellant and an initiator. So, that mold will contain the explosive propellant and initiator, and it inflates when it receives an electronic pulse from the crash sensor. Crash sensor sends the electronic pulse and then there will be a reaction, chemical reaction, which will generate some gases, and that will inflate the airbag. The fibers which are required for airbags are high strength, high thermal stability, it should absorb the energy, impact energy, and it should have good edging agents characteristics, but because it for in a car it will remain for long time. So, good edging agent characteristics should be there, a coating adhesion should be good, functionality under extreme cold and extreme hot environment. So, these are the basic requirements. The fibers which are used typically nylon 6/6 or polyesters are used. Other fibers aromatic polyester, aramid fibers, super high tenacity strength, viscose rayon, carbon fibers. So, these fibers are used, and nylon 6/6 is most popular because of we can have different wide range of linear density. Nylon have high strength to weight ratio, so high elongation at break, it is tough material, and 4% moisture again which provide quenching properties. So, economically available fiber, and if you compare the nylon with polyester, some airbags made from polyester show superior mechanical properties, flexibility and packing property. So, polyester does not exhibit humidity induced dimensional changes because of the very low moisture regain 0.4%, whereas for nylon it is around 4%. Nylon has high elongation under high load, high latent heat for fusion, lower density to polyester, long term property retention. Polyester is more suitable for seat belt and nylon is suitable for airbag. The disadvantage is that inferior to polyester in terms of humid resistant, because its moisture regain is high, light resistance and shape stability. The yarns basically it requires high strength, high elongation and uniformity. So, filament yarns are normally used, continuous filament yarns of 50 to 850 decidex wide range. Now, here we can see that different types of nylons are used. The fiber fineness, that is the fineness of the this nylons which are used, you can see that 350, this is the range. Yarn tenacity typically relate around 60 centinewton per tex, and for polyester it is 9.3 gram per denier. So, we can convert it. So, elongation it is high elongation here, but for polyester relatively lower than nylon. So, shrinkage is less than 6%, in hot water at hot air at 190 degree Celsius. So, shrinkage is not that high, and for fabric we require low thickness because of the foldability. We have to fold in a small container. The high tensile strength should be there, high anti-slip property of seam, that there should not be seam slippage, high dimensional stability, it should not change dimension with the temperature and humidity, defined and uniform air permeability should be there, reliability, and looms in rapier, water jet, air jet looms are used. Rapier provides fewer defects. So, water jet needs no sizing, better productivity than rapier. Air jet provides highest production rate. We can use any different types of looms. These are the different materials. See, molds, smaller pan and a bag type, driver, passengers, side impact, different types of bags we use, inflator type, hot and cooler, and inflator it is a excellent seam strength, and coated fabrics are used. So, different types of material and weave designs we can use, the basket weave, plain weave, ripstop, combination of twill and basket, different types of weave structure we can use, hop sack or fancy weaves are used, and weave effect. So, that is the, if we change the weave, the air permeability is getting affected, tensile properties, biaxial properties, physical bulk, these are the different effects of weave. We can use different weaves. So, injuries caused by airbags. So, after deployment of airbag, inflation of airbag, the secondary injury sometimes caused by the airbags. So, minor injuries like 96% categorized as a minor injury, as airbag slaps injured, such as grazing, brushing, abrasion of face, neck or upper limb. So, it can actually brush or it can actually abrade the face, because it is directly inflated and coming to the face. So, other injuries such as head injury, eye injury, internal organ, okay, that the different types of injuries due to the sudden the inflation. So, you can see if there is a sudden inflation, there will be sudden impact. If it is not that high impact, but there will be sudden abrasion. So, and there is a talcum powder in the eye. So, this basically the talcum powder is actually kept mixed with that is a sprayed on the airbag to keep it dry. So, when it is directly come into contact, so that talcum powder actually comes into eye. So, some eye irritation can take place. So, the main objective of airbag is to increase the interval over the force being applied, in that spreading the force over the large area of the body. So, knitted and nonwoven fabrics. So, knitted fabrics provide extensibility, nonwoven structure is least preferred. So, we do not use nonwoven structure here. mainly the oven structures are used. Finishing, different types of finishing we can incorporate there, like desizing, scouring and bleaching, heat setting we have to use, coating, different types of coating. So, coated versus uncoated airbags. Now, if you see the property, so air permeability for coated precise control, we can control the air permeability which is required for airbag, but in uncoated it is a variable, we can depending on the this thread density. Packability, because of the coating it is a bulky, it becomes stiff and it is bulky. So, packing is a problem, and here we can have small size packing. The fabric, the airbag has to be is packed in a small package. Stiffness, after coating it has become stiff and it is actually the uncoated become it is a pliable, and so it can be packed easily. Pattern cutting, easy to cut, it is more difficult because of coating, it is stiffer. Sewing, easy to handle due to the stiffness, it is a difficult. Burn through, good resistance, here it is a poor resistance. Deployment, excellent control, but because of the coating, but here it is edge combining effect. Cost, due to coating the cost is high, here cost is low. So, recyclability, due to coating material, so recyclability is difficult, here we can easily recycle. So, we can use both coated and uncoated. So, their comparative studies are given. So, scouring we can do for nylon, for polyester. So, high liquor ratio to avoid redeposition. Then lubrication is used, heat setting is done, airbag may change their shape on heat setting. Heat setting for dimensional stability it is required. Open width such as a stentor is used. Coating and lamination, so which reduces the air permeability, improves the tensile and tear strength. So, different types of coatings are used. So, the earlier type of polychloropen chemicals were used, which actually release discontinue due to which release the hydrochloric acid, low abrasion and wear resistance. Silicon based materials are used, neoprene coatings, multi coatings are used. The chemical used in an airbag, so it is actually pyrotechnic actually. So, this is basically pyrotechnic to create gas by chemical reaction. This pyrotechnic is used in airbag. So, along with the augmented devices, so which dilution of hot and high pressure gaseous product. So, these chemical reactions are done where the nitrogen gas generally are created. So, advantages are reduced propellant mass requirement, low air temperature, low dependence of the variations and more uniform performance. So, here for this equation the reaction sodium azide is the used in older airbags. So, decomposition, this is the equation, this initial rapid breakdown is initiated by heat from an igniter. So, the after getting the signal of any crash, the electronic sensor will ignite, send ignition, and this ignition will actually, this is the sodium azide, there will be a generation of nitrogen gas, and then neutralization, this reaction removes the highly reactive sodium metals, okay, and produce more nitrogen gas. So, the other additional gas is created. So, this gases, nitrogen gases will be filled in the airbag. Airbag will be filled with this nitrogen gas, and this is very fast reaction. And stabilization is there, where metal oxide react with silica sand to form a safe silicate glass. So, this metal oxide which is created here, okay, this metal oxides here, that silica sand is there, that which will actually form a safe silicate glass. The drawbacks of the sodium azide are the gas generated based on pyrotechnic or augmented devices. Augmented device inflators dilute the hot and high pressure gas produced from the propellant combustion. After that, the folding is there. There are different types of foldings, the L folding, the ring folding, accordion foldings are there, then stochastic foldings. These are the different types of foldings of airbag, and this after folding that has to be encapsulated, that will be put in the system. That the higher injury risk is there if we have L folding. And uncoated fabric recent developments are there. To counter the challenge of thickening, we use the uncoated fabrics. And to improve the foldability, smart restraint systems are there, single point electronic sensing systems, fast sensing for side curtains, child seat sensing, weight based sensing, combined capacitance ultrasonic and infrared sensing. So, different types of recent developments are there, and the future airbags should be more economical. There should be range of intelligent sensing, it should reduce the size, advanced applications should be there. So, these are the different future airbags. So, maintenance and life cycle of airbag, the routine check is must, indicator should be there, ends with end of life of the car. So, after the car's life is end. So, we should not reuse this airbag again. Removal of undeployed airbag before shedding. So, the environmental concerns are there, the issues are non-metallic parts are problematic while recycling. Identification of and separations are cumbersome, that there are different types of components in the airbag. So, identification and separations are cumbersome for recycling, which is uneconomical. Most of us for actually go for landfill. So, this are used in the landfill and which generates the toxic chemicals once again. So, proper isolation of plastic material and coating materials are the problematic problem. So, possible solutions are decopolymerization. So, acid and base catalyzed hydrolysis are required. Coated fabric can be recycled. Shredding of 10 airbags produce nearly 1872 grams of carbon dioxide and 8.9 grams of carbon monoxide. So, huge carbon dioxide will be generated. So, there are different testing standards like ASTM standard, air permeability, static and dynamic, bursting strength, breaking strength, tear strength, okay, and abrasion strength, fogging resistance test, flammability. So, all tests are done as per different standard process. Performance of airbags are also, they are evaluating the performance of inflatable resistant molds. Specific packability is tested, H-com resistant, different terminologies are as per the SAE J1538 standard, the glossary of automotive inflatable restraint systems. So, identification, physical properties, aging, visual inspection, okay, blocking tests, the different types of test standard are there for airbag. So, other it continues with different types of ASTM standards are there, fabric mass per unit length thickness, so pH, stiffness, so many tests, thread, sewing thread test. And we have now come to the course, that is textiles for human protection part 2. So, we have covered tried to cover the wide range of areas where textiles are used for human protection. I think you all have enjoyed these sessions. Now, thank you.